problem. It says find the number of CO2 molecules and 10.8 grams of dry ice. And dry ice is just CO2. So we have a problem. So let's think back to how we used to approach problems. So we said, first, what am I looking for? So it says I want the number of CO2 molecules. So I want CO2 molecules, okay? That's what I'm looking for. What did they give me? They said it's 10.8 grams of CO2. So I have grams of CO2 and I want to go to molecules. So let's think about this. I have grams and I want to go to molecules. All right? So remember, grams is something I can physically hold. Molecules is something really, really small I can't see. So we need to think back to first test stuff. If I have something I can physically hold to something I can't see, what is the bridge that gets me from something I could see to something I can't physically see? That was the mole. So remember, the mole was my bridge. I have to go from grams to moles, then moles to molecules. All right, let's refresh this. What did we say was my conversion between grams and moles? This was, remember, grams is like a mass, so this was like a mass to go from grams to moles. So that was the molar mass of, and that came from my periodic table. That's when we were doing an element, okay? So molar mass is correct-ish, but we're not doing an element, we're doing a compound. So now we just have to change the word from molar mass to molecular mass. So it's still MM, molar mass, molecular mass, and this comes from the periodic table. So the process is the same, except we're gonna have to do a little extra step to get this number mathematically versus just finding it on the periodic table. We have to use the periodic table and add it up. Then if I wanna go from moles to molecules, a lot of times when we did an element, we didn't write molecules here, we wrote atoms. And that was the thing to really help you. But if I'm trying to go to something I can't see, like an atom or a molecule, what did I use? So I used Avogadro's number. Okay? Avogadro's number. So the reason it's not atoms is because I'm dealing with a compound. If it was an element, then it would be atoms. But you should remember this is exactly the same pretty much. So let's refresh this. So this is the molar mass from the periodic table, but it's for CO2 now. So this is what we just talked about here in the previous slide. So since it's CO2, I actually have to use the periodic table and add it up. So I'm going to do that on the side here. So for CO2, I have 1 carbon and I have 2 oxygens. Okay, so the mass of carbon is 12.01 and the mass of oxygen is 16. So this is going to be 12.01, 2 times 16. I add that up and I'm going to get 44.01 grams per mole. Okay, so that is my molecular weight. So before, if it was just an element, this number was just the number off the periodic table. Still off the periodic table, but we had to do a little math. This is the new part. Avogadro's number is the same number we used last time. 6.022 times 10 to the 23rd. So that hasn't changed. So now let's work it out. So 10.8 grams of CO2. I don't want grams, so grams have to go on the bottom. And I have to go to my bridge. My bridge is the mole. Right? So don't want grams, so it goes on the bottom so it cancels, and I'm trying to get to moles. So I need something that relates grams and moles. We said the way I go from grams to moles is my molecular mass, or my molecular weight, and that was the number I added up. This number says it's 44.01 grams per 1 mole. So the 44 goes with the gram. So if the gram's on the bottom, the 44 goes on the bottom. And 1 mole. Grams cancel. I don't want moles, I want molecules. Actually, I can make that a little bit bigger. How do I go from moles to molecules? We said Avogadro's number. So what was Avogadro's number? It was this number is that many molecules or atoms in 1 mole. So that number always goes with my molecules. So if my molecules is on top, it goes on top. Moles cancel, I get molecules, I do the math, and I get 1.48 times 10 to the 23rd molecules of CO2. Okay? Now remember, how do I know if this is correct? If it's molecules, it's got to be a really big number because I'm going to have a lot of molecules and something I can kind of weigh out and put in my hand. There's going to be a ton of molecules. So this number, if it's molecules, should be 10 to some positive 20 answer. So I've got 10 to some positive 20, so I feel pretty good about it. All right? So this is the same thing you did before. The only difference was it was an element, and this number came right off the periodic table instead of adding it. So this is the only new thing is that we have to get this number via math versus just straight from the periodic table. So it's not completely brand new for you guys. All right, let's do another one. So how many molecules are in 50.0 grams of PbO2? And it says PbO2 is 239.2 grams per mole. So what am I looking for? All right, I'm looking for molecules of PbO2. What do they give me? So they gave me 50 grams of PbO2, and then they told me this number of PbO2. So now we have two numbers here, and we're trying to get to molecules. So we go, well, I don't even know where to start. Remember, we kind of start with the easier one. So which one looks simpler? This has 1 unit, this has 2. So this guy is going to be the easier one. So we'll start with him. Whoops. So we say, okay, I'm going to start with grams. I'm trying to get to molecules. So I start with something I can see to something that is unseen. I can't see it. So how do I go from something I can see to something I can't see? I have to go through the mole. Okay? How do I go from the grams to the moles? Okay, this is like a mass. So this conversion is a type of mass, and that was my molecular mass, which comes from the periodic table. Then how do I go from something, from my mole to something I can't see? That was Avogadro's number. All right, so now I want to go from grams to moles and I want to measure it up. But they gave me this number. So what is this number? It's in grams per moles for this guy. This number actually is the molar mass. Now, if you completely didn't realize that, you'd go to the periodic table, you'd say, okay, there's 1 Pb, there's 2 oxygens, you would add it up, and then when you added it up, you'd realize, oh, it's that number. So if you didn't realize what this was, then you would figure it out whenever you would try to do the math to find that. So sometimes they'll give you this number in the problem so you don't have to find it yourself. So then you recognize that you have it, and now you can just keep going on your problem. So I have grams. I want grams to go away, so it goes on the bottom, and I want moles. I need something that has grams and moles. This has grams and moles. Okay? 239.2 goes with the gram, and a number 1 goes with the mole. So the 239.2 goes on the bottom. 239.2 grams, 1 mole. That cancels. I don't want moles. I want molecules. How do I go from moles to molecules? Avogadro's number. Okay, and we said Avogadro's number is that many molecules in 1 mole. So we write the number with the molecules, 6.022 times 10 to the 23rd and 1 mole. Everything cancels. I do my math, and I get my answer to be 1.26 times 10 to the 23rd molecules of PbO2. Let me say, how do I know if it's right? If I'm looking for molecules, then it has to be a really big positive number. So this is a really big 10 to the 23rd. So we want this to be 10 to some positive 20-ish number. Okay? So big amount of molecules. So same like we just did, the only difference is how we got this number. In this problem, it was given to us, we just have to recognize what it was. All right, so this is going from grams to moles, and you can do it the opposite way. You could go from molecules to grams, you just have to flip everything, okay? So this is being able to go from grams to molecules or molecules to grams using your formula mass or your molecular weight. All right, next lecture, we're gonna introduce another new concept that we haven't really talked about before, and that's percent composition.